All right, good afternoon, everybody. Let's do this. So, first thing we're going to do is we are going to put our calculators away. So, take a minute, put your calculator away. Put your calculator away. All right, raise your hand when your calculator is away. Raise your hand when your calculator is away. Perfect. So, take everything off. Everything off. Thank you. I appreciate that. Yeah, no Desmos, no calculator, nothing. We're going to draw these without them. Okay, so there were 0 views on the lecture yesterday, so I'm going to repeat everything that I said. I'm just kidding. Okay, so let's look at asymptotes, horizontal and vertical. You know how to find vertical, and very soon we're going to just formally finish up how you get horizontal. So let's practice first before we finish our notes. What is the horizontal asymptote for this? Put it in the chat box. What's the horizontal asymptote for this rational function here? What's the horizontal asymptote? What's the horizontal asymptote? Oh boy, no correct answer, yes. Finally, x-axis and y equals 0. Yes, they're lines. They're lines. You're going to get marked off. What about this one? What about this one? What about this h of x function here? What about this rational function? What about this one right here? Very good. Yes, what he said. Let's be as easy as possible. Okay, so here's what's actually happening with horizontal asymptotes. Remember, this is not for if you put 2 in for x or -3 in for x. This is huge, enormous numbers in for x. Huge, enormous numbers. Okay, we're just putting in huge positive numbers. You'll get into more stuff in pre-cal as well. Oh, something I forgot to say yesterday to emphasize, and maybe I'll put it on a slide tomorrow. You know how I talk about like transformations, like, hey, you're going to be doing this in pre-cal as well, or like a lot of factoring, you're going to be doing this in calculus, and in pre-cal, you're doing these in pre-calculus. You're going to be doing this in pre-calculus, and you're going to be exploring them even more in calculus. So you're going to need this stuff for future math classes, like this exact information. And they're going to actually scaffold it up with a little bit different ideas. So essentially, if you have, if you're putting 1,000,000 in for x, this plus, and then you're putting it to the 4th power, this plus 5 doesn't matter. In fact, x to the 4th power, it doesn't even matter that you have minus 7x squared here. It really comes down to it's x to the 4th over 5x to the 4th. The coefficient does matter if the powers of x's are the same. So that means y is 1/5, or h of x in this case is 1/5. Good. Okay, so this is the COCO. What about this guy right here? Yeah, I guess. I don't know how that works. Yeah. And by the way, while you guys are putting in s of x equals, what's the horizontal asymptote for this? Yeah, guys, there's been a lot of audio issues at Lawler and the Chromebooks. I don't know how quality Chromebooks are compared to like laptops. I've just never used them, really. I know we have a bunch here, and they're cheaper than having, a bunch of Dell laptops or IBM laptops or certainly MacBooks. But yeah, if you're having a lot of audio issues and stuff, you can you're going to have to ask the librarian or the tech people there, because this is going on day after day after day, and it just seems like it's a roll of the die. Literally, there's 6 of you. It seems like it's a roll of the die who has bad audio or not. Okay, so what's the horizontal asymptote here? What's the horizontal asymptote here? Yeah, I mean, whatever. Yeah. Well, I'm surprised those didn't work. All right, can you hear now? Perf. Okay, what are the horizontal asymptotes? Awesome. Okay, we have a workaround. Is someone going to tell me what the horizontal asymptote for this is, or are we going to just talk tech issues all day? Send a link to where you called in. It's pretty simple. Y equals 5. What's another way to say that? What's another way to say that? Take a look at what the function is. You could also say S of x equals 5. Good, thank you. So here's what's happening. You can take away only large numbers of x. You can essentially take away everything after. And it really just becomes 10x squared over 2x squared. And you can cancel that to 5 over 1. So S of x equals 5, y equals 5. All right, what about this guy here? What's the horizontal asymptote here? What's the horizontal asymptote here? Good. Good. It's none. And what about the horizontal asymptote here? A, B, C, or D? What's the horizontal asymptote? Yeah, there's going to be none, because this would be negative 2x to the fifth plus 10 all over 1. So when you think of just your regular polynomial functions, there's no horizontal. That's why there's no horizontal asymptotes. They're unbounded. They're unbounded. Good. If you guys have a link to where you called in, did you guys use a phone or your cell phone, or did you call in elsewhere? They use phone. Okay, cool. Thank you. Yeah, infinity is kind of what we're getting at. You're going to get more into that in pre-cal. And let's get to the doc here, if it would let me share it. Okay. So let's finish all these bad boys out. Here's the COCO, the coefficient over coefficient, which is what a few of those were. We put the coefficient over the coefficient, like where it was y equals 1 over 5. The other was y equals 5. What's the domain and range? What's the domain and range for these guys? Know how to use all these notations. What's the domain? Okay, let's see here. Let's try it with interval notation, your favorite, right? Negative infinity, it's going to go negative infinity all the way to negative 5. So you take one piece at a time. Take one piece at a time. Domain, you go left to right. This is the most left piece. So you stick in just one interval, union with, and now you look at the second piece, the one that's on the right. You look at the piece that's on the right, and that starts at negative 5 and goes to infinity. Good. Now the set notation, let me quickly jot that down because you need to recognize that and be able to write it. The set of all x such that x is an element of the real numbers, comma, x cannot equal negative 5. Okay, that's the break in the domain there. What about range? What's the range going to be? What's the range going to be? And I have a comment on this. What's the range going to be? Okay, it's going to be negative infinity all the way to 2, and then union with 2 to positive infinity. So it never touches 2, never touches infinity or negative infinity, obviously. Okay, this is important because students sometimes get this wrong. I don't care that this is on the left, this is on the right. You don't care about left and right when it comes to range. Mess this up all the time. All I care about is the downward most piece. What piece is on the bottom? In this case, it's this. So you do the interval for that piece. Negative infinity to 2, not included. Then you take the topmost piece, because you go from bottom to top in range, and then you do 2 to infinity for that. And then the set notation, the set of all y such that y is an element of the real numbers. Y does not equal 2. Sweet. Yeah. Be careful. Y doesn't equal 2. Don't get a point off of that. Range is y. So now you know what all these boys are. Let's do this. We have BOBO. That means bigger on bottom. Bigger on bottom. Then put a slash through this. 0. Okay, it's not. That's a number. That's not an O. Bigger on bottom than 0. What's bigger on the bottom? What's bigger on the bottom? This acronym stands for bigger on the bottom. What's bigger on the bottom? What are we talking about? I didn't mean to do that. The exponent of x. Good. Yeah, not the coefficient. Oh no, did this freeze? Okay. Okay, whatever. There we go. All good. No. Hold on. The bigger on bottom. Bigger on bottom. Yes, true. No, that's true. We're not talking about any. We're not talking about any HK values. We're not talking about any K values, I should say. We're not talking about any K values. We're not talking about any D values. If you're using that letter instead, yeah, we're not talking about that. Okay, so let's cut to the chase here. You guys ultimately got 0.00334. What'd you guys get for 10,000? What'd you guys get for 10,000 in this table here? This was like 0.02045. So you can see how you had 2 pennies and now you have none. What did 10,000? Oh, okay. 0.000001, like all the way over there. Good. Okay. So the number y1 gets very close to is 0, and they give away the answer here. So what's the equation for the horizontal asymptote? It is y equals 0. Or what's the other way to say that? You can say the x-axis. Okay. Factor the denominator. Factor the denominator. What'd you guys get here? What did you guys get here? What are your factors? Yeah, so what were the factors then? What were the factors? Be careful. Careful. Oops. Yep. Anybody else? What were your factors? There we go. Yes, it's going to be x plus 5 and x minus 2. That's what the denominator factors to. So you have x equals negative 5 and x equals 2. So what are these things going to be? They're going to be your vertical asymptotes. All right, and now sketch the graph of the function. This is why I told you guys to throw your calculators away. We're going to have x equals negative 5. 1, 2, 3, 4, 5. All right, usually asymptotes are drawn with dotted lines. Okay, let's name this guy. This is x equals negative 5. And then we have x equals 2. another vertical line. Let's name this guy x equals 2. Name our asymptotes. And then y equals 0. So you can just put this along the x-axis here. Y equals 0. Now let's sketch. Let's sketch. We might have to test some points out. So if you tested, say, x equals 0, that's pretty easy to test. If you did x equals 0 in here, what would you guys get? What would you guys get if you tested x equals 0? Sorry, let me put test here because we need to see where this stuff's going to be. Sorry, up here. Let's x equals 0, put it into that. You could probably do it just mentally. You put x equals 0, you're going to get yes, thank you. So it's going to be negative 4 over negative 10 equals 4 over 10, and that equals 2 over 5. Okay, that one was pretty easy to do. And what about, like, say, x equals 3? Okay, we're getting on the other side. We were between the asymptotes before. 0 was probably the easiest one to test. Now we're to the right of x equals 2. Okay, so this is positive here. This is positive. What about x equals 3? If you plug x equals 3 in, that shouldn't be too tough. That shouldn't be too tough to put in. Good, and that's negative 1/8. So we have a negative right here. We have a negative right here. Negative 6 is going to be a little tough to put in. You would also test negative 6. You don't have a calculator. Normally, it would give you that. So here's what this is going to look like. Here's what this is going to look like. You're going to have a parabola, and we have 0 is at 2/5. So we can actually put a point here if we want. We're going to have a parabola that comes just like this. What I drew in pencil there. Okay, it's not going to touch the asymptotes. We're going to have a curve. Spoiler alert. Well, actually, we'll do the x equals 3. X equals 3 was negative 1/5, so we're going to be right here. So we're going to have a curve that you've sort of seen before with your, sorry, I want to curve that a little bit. What you've kind of seen with the rational functions before. And we're going to have a curve, spoiler alert, it's going to come like this. All right, didn't mean to touch the asymptote there, sorry about that. And this is what you're going to have as your sketch. Yeah, you would test negative 6 because you're testing around the asymptotes. So you test negative 6. 0 is probably the easiest thing to input. You can do anything between negative 5 and 2, and then you can do 3. Probably the lower numbers, the better, because you have a quadratic and all this stuff up here without a calculator. You don't want to be putting in like 11 or negative 15, something like that. That's harder to do, right? Okay, what's the domain? What is the domain? Let's use set notation, shall we? What is the domain? Let's do set notation. Oh, there's no range here. Good. So it's the set of all x such that x is the element of the real numbers, comma, x does not equal 5, comma, 2. What about the range? Let's put range here. Sorry, it's not listed. What about the range? Okay, notice there's two vertical asymptote. What's the range going to be? That's all right. Yeah. What's the range going to be? Set of all y such that y you could write both. Yeah, you could write both. Some people like to write x does not equal 5, x does not equal 2. You can do a list of answers when you're in set notation like that. All right, y is an element of the real numbers. Y does not equal 0. Yep, the x-axis is the horizontal asymptote. Okay, last rule. Last rule. All right, probably the two nicest looking clowns, I might add. BOTN. BOTN. When you guys completed this table, it went like 210, 410, 610. What do you guys get for 10,000? What happened with 10,000 on the Y's here? 20,000, 10? Okay, getting really, really big. So BOTN stands for bigger on top. And then I'm going to put this here because that's kind of just the rule. Bigger on top, none. Bigger on top, none, meaning no vertical asymptotes. There's no no horizontal asymptotes. Horizontal, Mr. Rand. No horizontal asymptotes. What number does y1 get very close to? It gets close to no number. Or you could put infinity, which isn't a number. And you could also say, I want you guys to have this in your notes, unbounded. It's unbounded. All right, do we need to factor the denominator where it's x minus 2? Do we need to factor the denominator? McKinley, do you mean in like a graphing calculator? Can you factor the denominator? Well, we just want a horizontal asymptote here. We're not looking for the remainders or what a value would be. The question is, can you factor the denominator? Do you need to factor it? The answer is no. What is the, if you set the denominator equal to 0, what do you get? Yeah, x equals 2. You just said x minus 2 equal to 0. That's the denominator set equal to 0. So these are the vertical asymptotes. So what's the equation for the vertical asymptote? There's only one. It's x equals 2. Perfect. So what do these acronyms help you find? What do these acronyms help you find? They're very valuable. You're going to need them next year. You need them this year. Can you simplify using synthetic division? Yeah, but that actually might hurt you, as you'll see in the next class or two. Yeah, I wouldn't simplify. I mean, you can probably investigate it further, but what's right here, you want to get that info first. Like if you're at a crime scene, you want to pick. I know you want to, chug all the blood you find into a DNA machine or send it to the lab, but you have to still take pictures and see where bullet fragments and all that stuff are. Take a look at what you have first before you start like using synthetic division and all the other weapons that you have. Okay, so COCO, BOBO, and BOTN, these scary, hopefully more charming clowns that we have. What do they help you find? This is how you find horizontal asymptotes. How do you find vertical asymptotes? Yep, you set the denominator equal to 0. Okay, you can then factor, and that's the first step, set the denominator equal to 0. You can then factor if it's possible. In this case, it wasn't possible. All right, awesome. The crime scene was, he was asking, why don't we use synthetic division to simplify? I was like, no. You want DNA evidence ultimately? Yes, but look what's here. What's going on here? Take a look right now. Highest power of x is in the numerator. There's no horizontal asymptotes. What's the vertical asymptote? Well, set x minus 2 equals 0. Like, get those. Get those instead of starting to think, oh, well, let's use synthetic division. Let's simplify it. Let's make it into a linear. Like, no, don't do any of that stuff yet. All right, so rest of class, finish it out. Do 1 through 4. Do 1 through 4. Let me know if you have any questions on any of these.